Currently, orthopedic casts are primarily made out of a plaster or fiberglass mesh. While these casts do successfully heal fractured bones, they have a tendency to cause hygiene, pressure, and heat-related injuries to the skin. Our experiment tested the viability of 3D printed casts, an alternative to the casts used today. The design of 3D printed casts allows patients to continue their routines of hygiene while reducing pressure. We aim to determine viability by testing the comfort and durability of each cast.
To begin our design process, we first used the CADing software Rhinoceros. Rhinoceros was used to create the Veroni cast, which has an emphasis on durability, pictured on the poster. A second cast we used was a pre-made HP cast, which uses a flexible structure. Both casts were made out of nylon. To test durability, we conducted drop tests using 5-pound weights from 3-inch increments. These tests ensued until there was a visible break that would hinder its functionality.
The casts were weighed and put under a drop test in order to compare them to plaster and fiberglass casts. The student design cast, also known as the Veroni cast, weighed about 90 grams, while the HP cast weighed only 40 grams. Under the drop test, the Veroni cast started showing signs of damage at about 12 inches, but it was very minimal. Damage worsened as the height increased. However, with the HP cast, the damage really only occurred at much greater heights. Due to the weak structure of the HP cast, it tended to bend under the pressure of the weights instead of actually resisting them. So while our graphs make it look as if it is stronger, in actuality the HP cast would never have protected someone's broken bone. The Veroni cast was actually much stronger because it was withstanding the pressure from the weights instead of being flexible and bending like the HP cast was doing.
So ultimately, our results are inconclusive. We were unable to complete our project due to time constraints. We would have liked to implement a scanning method into our design process to produce a cast tailored to one of our arms. This would have allowed us to test our cast for comfort. We also would have liked to obtain a control cast to compare our results with. This would have allowed us to use the same durability tests and conditions on the control and compare it with our results. Finally, we would have liked to implement an opening mechanism onto our cast. This would have been done by printing the cast in 2 pieces and attaching them using a hinge and latch mechanism, which would have allowed patients to easily put on or take off the cast if necessary.
Ultimately, while our experiment was inconclusive, 3D printed casts still show great promise in the field of orthopedics. The material and design of 3D printed casts promotes better hygiene and comfort. With the implementation of a 3D scanner, doctors can provide more patient-specific casts. Furthermore, given how new a technology 3D printing is, more research will only increase the possibilities of it. Already, in addition to 3D printed casts, 3D printed prosthetics and 3D printed implants are also being researched. To conclude, because of this adaptability, 3D printing, along with 3D printed casts, has the potential to become very important to the medical field.